All right, so we're going to start working through with parallel lines cut by a transversal. Now, each of these has a name or a way to describe how the angles match up in this scenario. Remember that a parallel line is a set of lines, so two lines that run together, and if they continued on and on forever, they would never touch each other. The transversal is what you see that cuts through the two parallel lines. So that is the line that cuts through. So let's go ahead and I'm going to go through quickly and describe which ones are which. Highlighted in red, I have done corresponding angles. Colored in orange, I have highlighted alternate exterior angles. In yellow, I have colored in vertical angles. In green, I have identified same side interior angles. In blue, I have identified alternate interior angles. And in purple, I have highlighted same side exterior angles. Now, when working with parallel lines cut by a transversal, I find it's easiest to ask yourself two questions. So here are the questions to ask. Number one, are they on the same side of the transversal? Remember, the transversal is that line that cuts through the center of the parallel lines. So it's the one that cuts it up a little bit. The second question is, are they both on the inside or the interior or the outside or the exterior of the parallel lines? Let's dive into this a little bit further. So the first that I want to talk about is corresponding angles. So as you can see, I asked myself the questions and wrote out my answers to them. So the first question about the transversal being on the same side of it, they are on the same side of the transversal. So if you notice, same side of the transversal. The second question is, are they both inside or outside of the parallel lines? For this case, one is inside and one is outside. Since that is the case, they are corresponding angles. The tip is they are in the same spot but on different parallel lines. So if I was to cut this in half, you would be able to take this original one and move it down to the bottom, and it would be exactly the same if you were to slide it. Now, in terms of how the degrees would work here, you would have the exact same degrees. So if this one was, let's say, 95 degrees, that means that the other corresponding angle would be 95 degrees. Moving on to the alternate exterior angles. So again, looking at the questions, I've written out those answers for you. So number one, about if it's on the same side of the transversal, the answer to this one is no. They are on opposite sides of the transversal. So another word for opposite is alternate. The second question to ask yourself is, are they both on the inside or outside of the parallel lines? For this one, they are both on the outside of the parallel lines. So they're not in between them. So that means that it is the exterior. Notice how the answers to those questions literally gave us the name alternate exterior angles. Now, let's say that we are trying to find the degree if we only have one of them. So let's say that this one is 45 degrees. They are going to have the exact same measurement. So if that top one was 45 degrees, then the bottom one would also be 45 degrees. The next one we are going to talk about is vertical. So again, I've answered those questions off to the side. Number one, about the transversal. Are they on the same side? The answer is no. They are on opposite sides of that transversal. So I'm going to look at, let's say this one here. They're on opposite sides of that transversal line. Oh goodness. So again, that transversal is the line that cuts through both parallel lines. Since they're on opposite sides, our next question is, are they both on the inside or both on the outside? And neither both are on the inside or outside. One is on the inside, one is on the outside here. Now, the tip with this one is that they are on the same parallel line, so it doesn't change. So they only correspond with those two in order to be vertical. So they're directly across from each other here. Let's say that one of them was 95 degrees. That means that, of course, the other one would be 95 degrees because they have the same degrees. They're going to be equal. The next one is same side interior. We're going to ask ourselves those questions again. So are they on the same side of the transversal? And the answer is yes. They are both on the same side of that transversal line. The next question is, are they both inside the parallel lines? And the answer to that is yes. They are both inside the parallel lines. So that means that they are on the same side on the inside. So it would be same side interior. Note how the answer to those questions tells you what type of angle it is. Now, for this example, you would have to subtract to find the degrees for what's left. So let's say over here that we have 45 degrees. Okay? We're trying to figure out what the other same side interior angle is. We need to subtract from 180. 180 minus 45 degrees gives us 135 degrees. That would be the measurement of the other same side interior angle. Next, we have alternate interior. So again, with those questions, are they both on the same side of the transversal line? And the answer is no. They are on opposite sides of that transversal line. The next question is, are they both on the inside or both on the outside of the parallel lines? And the answer is yes, they are both on the inside or the interior of the parallel lines. Again, notice how these key words in our answer tells us basically what the name of our angle theorem is. So these are going to have the same degrees if you are going to solve. Let's say one of them is 80 degrees. That means that the alternate interior one is also going to be 80 degrees. They're going to be equal. Last one, we have same side exterior. So we asked ourselves those questions again. We asked, are they both on the same side of the transversal line? And the answer is yes, they are both on the same side of the transversal. Again, this is giving us answers and part of our answer through the questions. The next question we ask is, are both on the inside or outside of the parallel lines? Yes, they are both on the outside of the parallel lines or the exterior. So again, looking at those questions helps us determine what the answer is based off of our responses to it. In order to find the degrees, again, you're going to have to subtract, just like with these same side interiors. So let's say that this one right here is, let's give it 80 degrees. So if this one was 80 degrees and we want to find the other same side exterior, we need to subtract 80 degrees from 180. That gives us 100 degrees as the same side exterior angle to the 80 degrees. I really hope this is helpful for you guys. Again, try and focus on answering those questions. Those questions are going to be super helpful for you. The code word for this assignment is SAIL. SAIL, SAIL.